Today, we're going to crack open a classic brain teaser, the 8 puzzle. But here's the cool part. We're not just going to solve it. We're going to see how a computer can actually think its way to a solution, not just by trying everything, but by using a clever shortcut to get there in record time. Okay, so here it is. You've probably messed with one of these before, right? The goal is simple. Get all the tiles in numerical order. It's a fun little challenge for a person, but for a computer, the real puzzle is, how do you find the most efficient way to solve it? To find that efficient path, we first need to get our heads around the 2 basic ways a computer can attack a problem like this. And really, it all boils down to a fundamental choice. Do you want to be thorough, or do you want to be clever? And this slide lays it out perfectly. On one side, you've got what's called a blind or brute force search. Think of it like trying to find your keys in a dark room by feeling every single surface. You'll find them eventually, for sure, but man, it's going to take a while. On the other side, you've got an informed search, which uses something called a heuristic. It's kind of like having a little flashlight that helps you make educated guesses about where to look first. So what is this secret sauce, this heuristic, that makes an informed search so much more intelligent? Let's dig in and see exactly how it works. So the key, the magic ingredient, is the heuristic. You can just think of it as a mental shortcut or a rule of thumb. It's a simple strategy that helps us make a really good guess about the best move to make without having to waste time checking out every single option. This guess gives us a score, or a cost, that's going to be our guide through this whole puzzle. For our 8 puzzle, we're going to use a really simple but surprisingly powerful heuristic. We're just going to count the number of misplaced tiles. That's it. The fewer tiles that are in the wrong spot, the lower our cost, and the closer we can guess we are to the finish line. All right, time to put this theory into practice. First things first, we need to calculate the cost of our starting position. That'll give us a baseline for the whole journey. So, here we go. On the left, you see our scrambled up puzzle, the start state, and on the right, that's our goal. That's what we want it to look like. Our mission is to get from start to goal as fast as we can. Okay, let's apply our rule. We just compare the start state to the goal state and count the tiles that aren't where they're supposed to be. Let's see. Tiles 4, 5, and 8 are all out of place. So that's 3 misplaced tiles. Our starting heuristic value, we'll call it our H cost, is 3. Okay, so we've got our starting HOSC of 3. Now let's see how this one little number is going to guide us to make the absolute smartest first move. Right off the bat, from where we are, we have 3 possible moves for that blank space. We can slide it up, down, or right. Now, a blind search would have to explore all 3 of those paths. But we're smarter than that. We're going to use our heuristic and calculate the H cost for each of these potential moves. So let's look at option 1. If we move the blank space up, our H cost actually jumps to 4. According to our rule of thumb, that move is actually taking us further away from the solution. That's a bad sign. What about moving down? Same story, an H cost of 4. So it looks like 2 of our 3 options are probably leading us down the wrong path. But then, look at this. If we move the blank space to the right, our H cost drops to 2. That's lower than the 3 we started with. Now that is a much more promising path. Well, the choice is a no-brainer. Our heuristic is pointing a giant neon sign at the path with the lowest cost, which is 2. By just ignoring those other 2 options, we've just saved ourselves a ton of computational work. All right, so now we're in our new state with that nice low cost of 2, and we just do it all over again. Rinse and repeat. We have 3 possible moves from here, up, down, or left. Let's crunch the numbers for each one. And check this out. Moving the blank space down gives us an even better H cost of 1. We are getting so close to the solution now. Only 1 tile is left out of place. The other moves, going up or left, well, those would actually increase our H cost back up to 3, which is basically going backward. So once again, the choice is crystal clear. And that's really the beauty of this whole thing. We don't have to overthink it. We just follow the numbers. The heuristic is our guide, and we just follow its lead to the most promising path. Okay, from our state with a cost of 1, it only takes 1 more move. We shift the blank space to the left, and boom, goal state. An H cost of 0 means every single tile is in its correct spot. We solved the puzzle, and we did it in just 3 super smart steps. That seemed almost too easy, didn't it? And that brings us to the single most important thing to understand about heuristics. It's all about a trade-off. This quote from our source material absolutely nails it. A heuristic is designed to find a good solution and to find it quickly. It might give you the absolute best, most optimal solution, but it might not. The one thing you can count on is that it'll give you a good solution efficiently. So here's that trade-off in a nutshell. The biggest advantage, the pro, is speed. Heuristics can turn problems that would take a brute force approach years into something you can solve in seconds. But, and there's always a but, right? The catch, the con, is that you sacrifice the guarantee of finding the absolute perfect solution. You're choosing a good enough solution that you can get right now. So what's the big takeaway here? Well, this matters because we all use heuristics all the time. Your GPS on your phone? It's using a heuristic to find you a good route quickly, not the mathematically perfect one that would take forever to calculate. We use these good enough shortcuts every single day to make decisions without our brains getting totally overwhelmed. It's a powerful reminder that the smartest path isn't always the perfect one. It's the one that gets you a great answer right when you need it.